In this configuration, you could have a drooping highline where you just release the highline itself. It droops down and it goes down to your patient, and you have your two horizontal movement lines to be able to move it back and forth wherever you'd like. You have different Reeves systems where you have a drooping line that then lowers down, various different ways of doing that. Very technical. You can get very technical. You can be very basic with this, but just make sure that when you set this up, you have redundancies for everything that you have set up so that you are able to move that patient to where you need to get them to in case something ends up going wrong. It's also important to note the rule of 12s when it comes to tensioning a highline, and that's going to give you the upper limit of tension that you can put into that highline. So when you initially tension the highline, put a 3-to-1 on it, get a single person on there, and have them tension it as much as they can, that one person. And then after you've loaded the highline, the rule of 12s applies. So take the number 12, divide it by the number of your mechanical advantage. So if it's a 3-to-1, 12 divided by 3, the result is 4. That's how many people you can have maximum pull on that mechanical advantage system to tension that highline. Otherwise, you're getting into some iffy situations on that force multiplication. You can do some damage if you're not careful. Also, if you have a pretty well horizontal system, you can get away with a single line on both sides doing the horizontal movement for the system. But if it is at a decent angle, you might have to then have 2 lines on the uphill side to have that redundancy in place in case something were to go wrong. You don't have a free fall downhill with serious consequences.